our first slide, which gives us the scenario scenario base for our discussion. So we just see this case study before we move on and see how to build a data warehouse for this particular case. So there is a builder who wants to build a huge shopping mall, right? So this scenario will actually help us to understand why exactly a model or a data model is important before we actually build a data warehouse or physical data warehouse. So in this case there is a builder who wants to build a huge mall, but he just has a very stylish architecture, and then he builds his mall without building mo uh, a model or the physical model. And so he actually didn't build a model before he built his building. He had all the uh, he had nice architecture for his building, but he forgot to see that there, after he built his building, he sees that there is traffic jam outside his mall. So what exactly this situation says is that if he would have built a mall, maybe he would have seen the he would have seen the proper exit. He would have had a proper exit strategy for his mall, and uh, he could have seen it better. I think that's what this slide means, that he should have a big picture before he actually starts building a data model, starts building the actual building. So if you would have so this act shows us that why model is necessary. So similar case is with our data model. So before you actually physically build a data model, you should build a blueprint of the data model, the which is called modeling, or an architect, a data architect, before he actually builds or proposes the developer to do something, he makes a blueprint of his data warehouse, which is called the model, and gives it to the developer or the users. And then after there is agreement, and then everything is checked with the users and the developers, then it is set for development, and then finally the data warehouse is built. So that particular scenario is that building of the model is called data modeling. So it is actually a gradual step where you first understand what exactly is the user requirement. Then you build first you build a conceptual model, which is the first then you move on to finally make a physical model where you have a proper data warehouse with tables and keys and everything. So this diagrams which helps us to represent a data model in a paper is called ER diagrams, which is ER means entity relationship diagram. So ER diagrams is the first step to build any data warehouse and to gather information from the users. Once the ER diagram is approved by the users, then you move on to build the physical data model. So we will see, so this is the process. There is a business owner who has a business requirement. Then he goes to, so they are comparing, in this slide they are comparing two different scenarios where you are building a building or you are creating a data warehouse. So the scenario on top is there is a owner and there is an architect who builds the blueprint. Then the blueprint goes to the engineer who looks at the blueprint and builds a building. Similarly, we have our clients, business clients. Then business clients give business requirement to the modeler. The modeler looks at the business requirement. He creates a blueprint or a data model for the DBS and the data developers. And the data developers look at the data model and build a data warehouse. So that's about the process of data warehouse building. So we will further look into what exactly is modeling and how we can represent this model in a in a paper or in a design document. So a model is basically abstraction or an abstract view or representation of the real world requirements or real world objects. So any requirement which is given to you by the user, you can actually put it on paper. That particular process is called modeling. So data model act as a blueprint, as I said. The tables that make up the data warehouse are mentioned in that particular data model, and the relationship between these two and the primary keys and everything related to your data warehouse, something like everything. So representing your metadata on paper is actually modeling. So it's not really metadata about your data warehouse, but it is. So as I said, metadata is built after your data warehouse is built, right? So this is not really metadata, but this is designing your data warehouse. This is the process of designing your data warehouse, where you put your thoughts on paper about what is it going to be when your physical data warehouse is built. So the data warehouse systems are long-term systems. So yeah, so as I said, to maintain the data warehouse, you should have a data model which a user can understand, and also your developers or maintainers can understand. So this particular model which you build should be clear enough for both the parties to understand. So that's why we do data modeling or put the model on paper. So what are the advantages of having a advantages of modeling? Assume that there is no data model and developers start building the warehouse. So once they start building the warehouse, they start implementing everything. They have bought the tools to implement that particular data warehouse, and then they have built the physical tables, and they bought database space or servers to implement the data warehouse, and then they finally realize that, okay, based on our data model, it looks that what we are doing is wrong, and then they have to go back and redo everything. So without having a model in hand, if you start developing something, you will always end up always encounter issues along your process of building a data warehouse. So it's you cannot start building a data warehouse without a data model which both your users understand and agree, say, and then you check whether your data model can achieve whatever the users need, and your developers say that yes, we can implement this. So this visual representation of the data model is very necessary for the business, for building a data warehouse. So the first step or the first way to represent a data model is the entity relationship diagram. So there are two terms, if you see in this term, which is entity and relationship. These type of diagrams are also called as ER diagrams. In general, you will hear in data warehouse market or in companies or projects, they call it ER diagrams. It's the abbreviation for this. So these ER diagrams actually has two information inside. One is entities and one is the relationship between these entities. So what is an entity? Entity could be any real world object. Like I would say entity could be assumed to be as a proper noun. So an employee, a company, a store, a customer, or a concept like medication can also be an entity. So it's a noun. I would say entity is a noun. So In the example you are seeing in the slide, there are two entities. One is a teacher entity and there is a student entity. Each entity, so each entity have different entity instances inside. So T1, T2, T3, T4, T5, there are different records in that entity table. So that is entity. That's about the entity. But this diagram also contains the relationship between two entities. For example, one entity, like in the example we saw just now, teacher and student. So the students, teacher teaches the student. So the teacher teaching the student is the relationship between these two entities. And similar example given here is employee works for a company. So employee working for a company is the relationship between employee and the company. So this entity relationship diagram will give you the different entities in your concept or in your data model, and also the different relationship it has. So the relationship can be of different types. So when we can see that so what I said is the relationship can be of multiple types. So it can be either one to many, many to many, or one to one. So these are different kind of relationship or two entities can have. What I mean by one to many and one to one and many to many, we will discuss further. But this concept, this type of different types of relationship is also called as cardinality. So a cardinality is the relationship between two entities in a ER diagram. So not only in the ER diagram, but generally between two entities. Yeah, it could be your database entity or it could be your entity in the real world. Like for example, the teacher, right? A teacher can have many students. For example, in a school there is only one teacher but there are many students. So a teacher can have many students but a student can have only one teacher. So the relationship between teacher to student is one to many. So that's what I mean, that this type of relationship is called cardinality. So yeah, so the first type of relationship is one-to-one relationship, in which each element in one entity is related to only one element in the other entity and vice versa. So in this case, there is an employee entity and there is a PAN entity. PAN entity is just the entity uh, which stores the PAN card number or whatever. But let's take an example, relevant example, like there's an employee entity and say there is another entity which is say a department entity. So one employee can only belong to one department, and sorry, this is not correct for the one-to-one. So let's say passport number. So similar to PAN number, right? One employee can have only one PAN number, and one PAN number can only be related to one employee. So in this case, or both the entities have a one-to-one relationship between themselves. And sorry, an instance in an entity has one-to-one relationship with the instance in another entity. So that is one-to-one. The next type of cardinality is one-to-many. In this case, as the name suggests, one entity from one instance from one entity is related to many instances in the other entity. So in this case, the example which is shown here, there is one company which has company 1 which has 3 employees, employee 1, 2 and 3. So one company from the company entity has many employees, but one employee from the employee entity has only one company related to it. So this type of relationship where one instance of an entity A is linked to many instances of another entity B, but one instance of entity B is linked with a single instance of entity A, is called one-to-many relationship. So in this case, there is a one-to-many relationship from company to employee. So that is one-to-many relationship. The next one is many-to-many. So in this case, as you see in the example, there is a project entity and there is an employee entity. So in one employee can work for different projects. So in this case, employee 1 is working for both project 1 and project 2. But employee and one project can have multiple employees, obviously. So in this case, there is a many-to-many relationship between the two entities. So a many-to-many relationship is is a relationship in which one instance of an entity A is linked to many instances of another entity B, and one instance of entity B is linked to many instances of entity A. So it's both sides, they are related many to many. So that is many to many relationship. So these are three different types of cardinalities: one to one, one to many, many to many. So that's about the relationship between the entities. The next topic we are going to discuss is the different type of models which you can represent using your different type of models you can have before you build the data warehouse. So as I told you before, they can be the first step to build a data warehouse is a conceptual data model. Then you have a logical data model. Then finally you have a physical data model. So this is the different types of data models you can have. It's different types of blueprint which is meant for different audiences. So we will see in the slides, forthcoming slides, what are these models and why are these built and who is the target audience for all these data models. So as I said, the first model which we built for a data warehouse is a conceptual data model. As the name suggests, it's just a concept of your data warehouse. So it gives you a very high level overview of your data model. Creating a conceptual data model is the first step. As I said, it's the first step in creating your data warehouse. This model is designed based on collecting requirements from the client, from the users. Then you would discuss with your counterparts, your client counterparts, and you discuss with your business users and about their requirements and the report requirements which they have. Based on that, you actually build this conceptual data model. So once you develop this conceptual data model, which will be in a very simplistic manner, so that even users and consumers, the consumers and the business users from your side can understand. So once this is developed, then you will share the details with the users, and once it is confirmed and both of the client and the modeler has this is confirmed that have the same understanding, then you will proceed with the other data models. Once if it is not approved, then you will stick with the conceptual data model and then correct your conceptual data model before you move on to build your logical data model. So this is the first step. So this will not have any technical details inside. It will not be very useful for your developers. It will just give you a business overview. So this is a sample conceptual data model which you see here in this slide. There's a simple sales fact table and then there are three dimensions: product dimension, store dimension, time dimension. So once you these three so looking at this conceptual data model, you can say that you have a sales fact table and the sales fact entity, you have a product dimension entity, you have a store dimension, you have these three dimensions and one fact table, and each dimension is related to this fact table. That is it. That is simple information you can get from this conceptual data model. So this is very high. It doesn't show you what different measures your fact table has or how these tables are related, nothing. So it just gives you there are there are four tables and they are related to each other. So this particular conceptual data model is for a supermarket who wants to measure the sales fact. I think this example we discussed a lot of times. So this conceptual data model was come up by asking questions to the client, like what exactly you want to measure. The client said, we want to measure the sales figures. So we put a sales fact. And then they asked the question, what are the various dimensions associated with this sales fact? So this conceptual model, which which is shown in this slide, is come up by asking questions like what to the clients, like what does the supermarket store want to measure. So by that we came up with the sales fact. The client said they want to measure sales figures, so we had a sales fact inside this conceptual model. What are the various dimensions associated with the sales fact? What different dimensions in which you want to see the sales fact? Bifurcated in what different dimensions? So they wanted to measure the sales by customer, by product, so you added different dimensions. So this particular diagram, this entity, the entity and the relationship are defined in this diagram, but the attributes, keys, etc., as I said, is not defined. So this will just give you a basic overview of the data model. The next data model which we will deep dive into after the conceptual data model is logical data model. So the logical data model actually contains more information and more technical information than your, not really, I wouldn't say technical, but it has more information than your conceptual data model. This is an extension of a conceptual data model. This describes more about your entities, different entities you have in your data model. This will tell you this will define the relationship, what kind of what columns are involved, attributes are involved within the entities, what attributes actually relate these two entities, what is the primary key, foreign key linkages, what are the, and also different you can see different dimensions in your model being normalized into other dimensions, but in your conceptual model you will only see a concept of your dimension. You won't see that, okay, this dimension, how the dimension information is stored in the logical model. Is it normalized, the data, is the data being split into different tables or what? You won't actually see that in your conceptual model. You will only see that in your logical model, where they will say, okay, we have two different tables which is shown, which is actually storing the dimension, this dimension data. So this level of information you will see in the data model, but still I would say it will not have information for the developers to start developing. So this conceptual model will definitely give you different attributes, like you see in this diagram. There's a you will show you what different primary keys it has, what different uh, uh, what is the column which is responsible for the relationship between the two tables, and you will see the relationship being shown. You will see the measures and the different columns in a particular table, but still you don't have the exact information for the developers to develop. So this representation is still not for the developers, but it's just a logical data model. It will show you different tables, different columns involved in the table, and then the relationship between these tables. So the example you see here, there is a product dimension, store, sales fact, and time dimension. So you see what is the primary key for each dimension, and for the and different foreign keys in your fact table and different attributes in your fact table. So this is what is a logical model, but it's still not informative enough for the developers to start implementing. So the next one is the physical data model, which is actually the a representation of your physical database which you have formed or designed. This is one step further with the logical model. So in the logical model you saw that you already know what are the columns, you already know what are the attributes related, so not the columns but the attributes related. You already know the different tables in your data model. But in physical data model you will actually see what are the data types of these different attributes. What is the primary key constraint? What are the different constraints on your particular table? Everything related to your table and the data model will be put in this table, shown in this model, where by looking at this data model you can actually write SQL scripts, DDLs, to create the physical tables in your database. So it will have all the informations. So for example, if entities will become from conceptual data model to logical data model, the entities will still the term we use in the conceptual and and the logical data model for is entities and attributes. But as soon as you move from logical data model to physical data model, the term entities becomes tables, attributes will become columns, and you will have data types associated with each column. You will have all the physical primary keys, foreign keys defined, column constraints defined. So, and also because you are defining everything, which is for a database, it will always depend on the underlying database you are using. Like for example, the data types in Oracle and DB2 might be different. So in Oracle maybe use varchar, in DB2 you might use some other terminology for the same character data type. So you can have different representation for different databases. So physical data model will actually be different for different databases, but logical excuse me, logical data model and conceptual data model doesn't depend on the underlying database. So you will define your physical data model in such a way that a developer can look at your physical data model and actually write SQL statements onto your database and create the physical objects. So this is the data model which is necessary, and this is the data model which is necessary for a developer to proceed and create his physical tables and physical relationship, indexes, everything will be in this physical data model, table space, and all the technical details. So that is the final data model we'll arrive at after performing all the after going step by step from conceptual to logical, from logical to physical. So this is a sample how your physical data model will look like. So you can see in this physical data model, you can actually see the constraints on dimension table, store dimension table, where you see there is a constraint, not null constraint on a particular column, which is store name. So which means that the store name cannot be null. So, and you can see the data type defined for each column, which is char 50 for store name, char 50 for address, and then you can also see the primary key defined on these tables. Similarly for all other tables, the data types defined, the constraints defined, the relationship defined. So your physical data model will show everything related to your tables. So this is where your entities become tables and attributes becomes columns. So that's about the three different data models. But let's look at this before we move further. Let's look at the comparison tables just to give us more understanding of these different models. So let's look at the left side question and imagine we have these questions on the left side. So let's see what is the answer to these questions in yes or no in these different data models. So are the entities and relationship shown in conceptual data model? Yes, you can see the entities and relationships. In a logical data model, yes, you can see the entities and relationship in a logical data model. But you see physical data model, it's not applicable. Why it is not applicable? Because in a physical data model, there is no entities and relationship anymore. It is tables and the integrity constraints and database constraints. So the terminology changes from logical to physical. So there is this particular concept of entity and relationship is not applicable in the physical data model. Similarly, attributes. Are the attributes mentioned? Yes. Conceptual, yes. Logical, yes. But in physical data model, this is not applicable like the previous case. What about the primary keys and foreign keys? So the conceptual data model doesn't give you this information about primary keys as we discussed. So it will only give you the entities and then it will give you the relationship. It won't give you the columns which are responsible for foreign keys. But your logical data model, yes, it will give you. And your physical data model, yes, it will give you foreign key relationship. What is the column or the attribute responsible for that relationship? So are there table names in the conceptual data model? No, because there are no tables. There are only entities and relationship in a conceptual model. Logical data model? No, it is not applicable actually for both conceptual and logical, because until then there is no bifurcation of entities and relationship as tables and columns. And are the column names and data types mentioned? No, they are not mentioned in the first two, logical and conceptual. It is only mentioned in the physical data model. Is this database, is it a database dependent? Is it database dependent? Okay, so as I discussed, conceptual and logical data model does not depend on the data underlying database. We are going to build the actual database. But physical data model depends on the underlying database, because different database softwares can have different data types and so on and so forth. Are other database objects like views specified in the conceptual data model? No. As I said, there will be only entities in the conceptual data model. There are no tables, no views, no database objects. In logical data model also no database objects. The database objects you will see only in the physical data model. What kind of users is targeted? Okay, yeah. So this is a question, right? When you build a data model, who are you actually building this model for? The conceptual model, you build it for the business people who can actually read it easily, and the logical data model is for business and more, I would say not only for business, but it gives you more information. So it could be for the architects, different data architects who is not related to the technical implementation of the data warehouse. So functional consultants can look at the logical data model to understand the different reports, or yeah, different understand the requirements. But the physical data model is only for the developers. It's very technical. It gives you everything related based on the underlying database, and it gives you all the technical details to implement this data model in the database. Create create the actual database using the physical data model. So that's about these models. I think we are done with the session.